Hello, let's solve this problem. From the figure we have to calculate x. Since we have to calculate the measure of an angle and we have triangles in the figure, it's important to remember some basic properties about triangles. The sum of the measures of the three interior angles is equal to 180 degrees. The measure of an exterior angle corresponding to one vertex is equal to the sum of the measures of the interior angles corresponding to the other two vertices. These are the two main basic properties you have to remember when trying to solve a geometry problem, mainly in cases in which you need to calculate or relate angles. Any isosceles triangle is actually symmetric with respect to the straight line that is perpendicular to the base at its midpoint. That line is called the axis of symmetry. Based on properties of congruent triangles, one can demonstrate that there are angles with the same measure as shown in the figure. See for instance the angles with measures alpha, beta, and theta. Okay, let's go back to our problem. In triangle ABC, there are two interior angles with measures equal to 50 degrees. Then the measure of angle ABC should be 80 degrees to complete the 180 degrees. And the triangle ABC is isosceles. To take advantage of the symmetry properties in the isosceles triangle, we draw the axis of symmetry. Remember that we already know that the measure of angle ABC is 80 degrees. Then, due to the symmetry, we have two 40-degree angles at vertex B. To take advantage of the symmetry, we can also draw the straight line segment NC. Then, the measure of angle NCA should be equal to the measure of angle NAC, which is 30 degrees. Also, the measure of angle BCN is equal to the measure of angle BAN, which is 20 degrees. Then, the measure of angle NCQ is 10 degrees. And, as you can see, CQ is part of an interior angle bisector. Due to this finding, we should remember something about interior angle bisectors. In any triangle, the three interior angle bisectors intersect at one point called the incenter of the triangle. To determine the position of the incenter, it is enough to get the intersection point of two interior angle bisectors. The third interior angle bisector should necessarily contain the incenter. In other words, in the figure shown, theta is equal to sigma. This is something that one can demonstrate using properties of congruent triangles. Going back to our problem, because CQ is part of an interior angle bisector, we should think that there is a possibility that the point Q is the incenter of triangle BNC, but that is something we would need to confirm. That is why we try to calculate the angles at vertex N. If you focus on triangle ANC, you can see that angle QNC is an external angle. Then its measure is 30 plus 30 degrees. That is 60 degrees. Now focus on triangle BAN. Angle QNB is an external angle. Then its measure is equal to 20 plus 40 degrees. That is 60 degrees. We see that NQ is part of one interior angle bisector. Then we are confirming that Q is the incenter of triangle MBC because Q is the intersection of segments NQ and CQ, which are parts of two interior angle bisectors. Consequently, BQ should be part of the third interior angle bisector. That is, the measure of angle MBQ is equal to the measure of angle QBC, which is X. Now you can see that the measure of angle ABC, which is 40 degrees, should also be x plus x. Then 2 times x is equal to 40 degrees, from which you obtain that x is equal to 20 degrees. Great, we have completed the solution. For solutions to other problems in pre-university or university topics, visit 4duni.com. Thank you for watching this video. Until next time.